Section 3. Setting up cluster networking in Kubernetes. In this section, we will demonstrate the Docker networking model, the Kubernetes networking model, and the implementation of the Kubernetes model. The Docker networking model. In this video, we will demonstrate how containerized applications communicate with each other, the host, or an external network. We'll demonstrate Docker networking design challenges for maintaining application portability, service discovery, load balancing, security, performance, and scalability. We'll cover the Docker networking architecture that is built on a set of interfaces called the Container Networking Model, or CNM, and how it provides application portability across diverse infrastructures. Docker containers can be connected together or to non-Docker workloads. Docker containers and services do not need to be aware that they are deployed on Docker. Whether your Docker hosts run Linux, Windows, or a mix of the two, you can use Docker to manage them in a platform-agnostic way. So let's review some of the Docker networking challenges. The first one is portability, and what this means is guaranteeing maximum portability across diverse network environments while taking advantage of unique network characteristics. The second challenge is with service discovery, and we need to know where services are living as they are scaled up and down. Another challenge is with load balancing, or sharing load across services as services themselves are brought up and scaled. We also face a challenge with security, segmenting to prevent the wrong containers from accessing each other, basically guaranteeing that a container with application and cluster control traffic is secure. Another Docker networking challenge that the platform addresses is with performance, providing advanced networking services while minimizing latency and maximizing bandwidth. There's also a challenge related to scalability, and ensuring these characteristics are not sacrificed when scaling applications across many hosts. So the Docker engine is able to perform the following. It manipulates IP table rules on Linux. It manipulates routing rules on Windows servers. It also forms and encapsulates packets and handles encryption. And the above facilitates connecting containers across hosts and exposing applications running in containers as web services. The Docker default bridge network. The bridge is the default network type in Docker and is an isolated network used when your applications run in standalone containers that need to communicate. The default bridge network is present on all Docker hosts. If you do not specify a different network, new containers are automatically connected to the default bridge network. Containers connected to the default bridge network can communicate with each other over IP address. We can use the Docker network create command to create a bridge network. And after you create the network, we can launch containers on it using the Docker run command with the network option. Containers launched into the isolated network that we just created must be on the same host. And we can expose and publish container ports on containers in this network to make applications available to an outside network. The bridge is the default and is used when your applications run in standalone containers that need to communicate. Host removes network isolation between the container and the Docker host and uses the host networking directly. Another Docker network driver is overlay, which connects multiple Docker daemons together to enable swarm services to communicate with each other. Overlay facilitates communication between a swarm service and a standalone container, or between two standalone containers on different Docker daemons. It removes the need to do operating system level routing between these containers. There are two more Docker network driver types. One is MAC VLAN. So the MAC VLAN network allows you to assign a MAC address to a container, making it appear as a physical device on your network. The Docker daemon routes traffic to containers by their MAC addresses, allowing legacy applications to be directly connected to the physical network, rather than routed through the Docker host network stack. The None network driver disables all networking and is usually used in conjunction with a custom network driver, and is not available for swarm services. So if you take a look at this diagram of the Docker Container Networking Model, or the CNM, you'll see that there is a network sandbox, and the sandbox contains the configuration of a container's network stack. This includes management of the container's interfaces, routing table, and DNS settings. An implementation of a sandbox could be a Linux network namespace, a FreeBSD jail, or other similar concept. A sandbox may contain many endpoints from multiple networks. In the CNM model, the endpoint joins a sandbox to a network. The endpoint construct exists so the actual connection to the network can be abstracted away from the application. This helps maintain portability so that a service can use different types of network drivers without being concerned with how it's connected to that network. The network component. The container networking model does not specify a network in terms of the OSI model. An implementation of a network could be a Linux bridge, a VLAN, etc. A network is a collection of endpoints that have connectivity between them. Endpoints that are not connected to a network do not have connectivity on a network. To summarize, the bridge is the default network type in Docker and is an isolated network used when your applications run in standalone containers that need to communicate.